400 gram of liquid A, molar mass 140 gram per mole, was dissolved in 1000 gram of liquid B, molar mass 180 gram per mole. When is 180 grams? So I can think of this as this one. I can think of this as glucose, but there can be more on other substances, other solvents or compound or liquid that has 180 grams per mole. Now the vapor pressure of pure liquid B was found to be 500 torr. Calculate vapor pressure of pure liquid A and use vapor pressure in the solution if the total vapor pressure of the solution is 475 torr. So let me bring out everything I have. So what I have here is liquid A. I'm going to just be putting it. Liquid A has mass. Mass of A is 100 gram. Then its molar mass. Molar mass of A is 140 gram per mole. Then was dissolved in pure liquid. Was dissolved in pure liquid, which is 1000 gram. So mass of B is 1000 gram. Molar mass B. Molar mass of B. Molar mass of B is equals to 180 gram per mole. And they're asking me the vapor pressure of pure liquid. They said the P naught vapor pressure of pure liquid. If they don't say it's the vapor pressure of pure liquid, they can tell me, they can say, if they don't tell me it's the P naught, they can say that the vapor pressure of liquid B at so temperature, I know it's still P naught. So P naught B, yes. So P naught B was found to be 500 torr. Now they say calculate the pure vapor pressure of A. We don't know it, and its vapor pressure in the solution, that is vapor pressure of A due to its presence in the solution, we don't know it. Now the total vapor pressure, that is PT, is equals to 475 torr. So if you look at it, we've analyzed everything we are given in this question, and on analysis, this is what we have. So we've analyzed this, and this is what we have. So this is it. I don't need to be looking at the question again. I've gotten everything I need from that question. So they gave me P total vapor pressure. And whenever I'm giving total vapor pressure, I need to remember that there is a man called John Dalton that gave us that there is a law for vapor pressure and there is a law for total vapor pressure or total pressure. He said that the partial pressure or partial vapor pressure, because if I have a solution, the solute is a part of it, the solvent is also a part of it. So he says that the individual sum of the partial pressures or partial vapor pressures gives you the total pressure. So this is his law. This is the law. So if I know this law, what it means is that applying Raoult's law, I can also know that this means PT equals to PA. According to Raoult's law, is PA naught XA plus PB is the same thing as saying P naught B XB. So if I apply Raoult's law, This is also equal to this. Then if I apply the second principle, where I used one to discover the other, I can also have, that is in a case, this is a case where mole fraction is given. It's easy. This is a case where I'm giving the partial pressures, I just sum it up. But I can have a case where mole fraction is not given. So I will apply this principle, which says that PT equals to PA XA. Then remember that XB can mean the same thing as saying PB1 minus XA. So in a situation where I'm not giving mole fraction, I will use this to get my mole fraction so that I can make this subject of the formula at the end of the day. So see what I mean. I'll have now PT equals to PA XA plus PB minus PB XA. So if I look at this very well, I'll see that I can choose to say, I'm trying to make XA subject of the formula because this is a case where they did not give me mole fraction, but they gave me P2, they gave me everything. So I'll simply try to make A subject of the formula. I'll say let this cross equality sign is having plus. So it will now become PT minus PB equals to PA XA minus PB XA. XA is common to these two. So let me factor out XA. XA will be equals to PA minus PB. Look at it very well. So if I have PA minus PB, if it times this, it becomes, if it times this, it becomes this. So equals to PT minus PB. I'm trying to make X a subject of the formula. I will divide both sides by PA minus PB. So that this will easily cancel this, equals to PT minus PB all over PA minus PB. And remember, please, this is vapor pressure, not P naught. So it's carrying this. Even when we multiply it, it's carrying this. It's supposed to carry this, supposed to carry this. So even that time that this one crossed over, supposed to carry this, because remember, it's this P naught now that we started here, that we have here. So if I know that, you see that at the end of the day, I've been able to get XA. So if I've gotten XA, I can now say that XA is going to be PT minus PB naught all over PA minus PB naught. So whenever I am giving total pressure, giving everything, and I'm not giving mole fraction, I can use this one as well. So these are the three formulas you can use, 2 and 3. And this 3, this is the final thing you're doing with the 3. What you get from that 3, product of the 3. So these equations, you make use of it. So now that I know this, I can go ahead to see if I can solve this question. So now that I know all these things, so let's try to apply it. Let's see. In this case, we can get mole fraction because we are giving mass and we are giving molar mass, giving molar mass. So we can simply convert it to moles, then get the mole fractions, then come and put. That means the formula we will use is simply the second one. So let's try to do it. Let's get the mole and the mole fraction. So to get the mole of A, so to get mole of A will simply be equals to 100 divided by 1/4, 100 gram divided by 40 gram per mole. So let's punch. I want to use calculator and punch that. So for 100 divided by 140, we are getting 0.7143 mole. Then for mole B, we simply do 1000 divided by 180 gram per mole. So 1000 divided by 180, we get 5.5556 mole. Now this is approximately 5.6 mole, and this is approximately 0.71 mole. Cannot be carrying small digit. So this is my moles. So to get the total mole, I'll get the total mole. One thing is to know what mole fraction is all about. It's simply, to get mole fraction is simply mole of constituent divided by total mole. So that's why we're getting the total mole. We simply do mole of A 0.71 plus mole of B 5.6, add it together, 0.71 plus 5.6. So you get 6.31 mole. So now mole fraction of A is going to be its mole, which is 0.71 all over 6.31. Then mole fraction of B, I want to divide this. Mole fraction of B is going to be its mole 5.6 divided by 6.31. So let's do it. So I'll have 0.71 divided by 6.31. I get 0.1125. 0.1125. Then 5.6 divided by 6.31. I get 0.8875. 0.8875. So this is mole fraction of B, mole fraction of A. So now that I've gotten this, you see that life is easy, because it will make things easy for me. Just go to equation 2 and pick it up. That's the one we are using. So I'll pick equation 2, which is PT equals to PA naught XA plus PB naught XB. So PT from the question, they gave me PT to be 475 torr. All these things given to me. So you can use book, write it out then, so you can be following us as we are progressing. So I'll come and do it. I'm giving PT to be 475. Then PA naught, I don't know it. PA naught, I don't know. Then XA, the mole fraction of A, I've gotten it to be 0.1125. Then plus the PB naught is 500 torr. Then XB, mole fraction of B. Mole fraction of B is 0.8875. So you see that the only thing that is remaining here is this. So let's solve for this. Then make PA naught subject formula. So let's punch 500 times 0.8875. We get 443.75 plus PA naught 0.1125 equals to 475. So you can see that at this junction, I can simply do, let this cross equality sign so that you have 475 minus 443.75 equals to PA naught 0.1125. So if you do this well, let's do it. So let's do 475 minus 443.75. You get 31.25. So you get 31.25 is equals to PA naught 0.1125. So you can see that at this junction, life is easy. You can divide both sides by the coefficient of PA naught, which is 0.1125. 0.1125. This will take care of this. So PA naught will simply be equals to, let's do it, 31.25 divided by 0.1125. You get 277.78. And remember, the pressure used for each is torr. So this is approximately 278 torr for the pure pressure, PA naught. Now remember, the question said that we should find two things: the pure vapor pressure and the pressure of A due to the solution. Remember I told you in my last class that that Raoult's law states that PA, for example, P vapor pressure. For example, if I say a body, water and glucose is mixed, glucose is mixed to form solution, and at the end of the day they come and ask me, find the vapor pressure of water. The one they are talking about is PA. Or they tell me, find the vapor pressure of glucose. The one they're talking about is PG. That is vapor pressure due to the fact that it formed a solution. But assuming they told me, find the pure vapor pressure of water, or pure vapor pressure, or find vapor pressure of pure glucose or pure water, or they tell me that I should find the vapor pressure of water at a particular temperature, that is going to be P naught of water, which is the pure vapor pressure. I need to know this. So in this case now, we've gotten the pure vapor pressure of liquid A. So we need to remember that liquid A, due to the fact that it formed a solution with liquid B, is going to be given by Raoult's law, which says that the vapor pressure of a constituent that has formed a solution is equal to the product of its pure pressure multiplied by its mole fraction. So to find this PA is simply going to be by doing 277.78 times its mole fraction, which we got to be 0.1125. Wait, are you kidding me? 0.1125, yes, that's what we got, 0.1125. So multiply by 0.1125. So if you do it, let's do it together. So 277.78 multiplied by 0.1125. So PA will be equals to 31.2503. which is approximately PA is equals to 31.25 torr. So approximately, you can say approximately 31 torr better. So this is your answer. This is your answer. So in our next class, we'll take more examples on this. Thank you. Subscribe.